Thank you all for joining us for the second day of our fall continuing education conference. Here's just a couple of quick, reminders about the process itself. So our slides are available. They are on TURI's website, and this is the location of the website. Also, if you go to our website and scroll down from the home page, there is something right in the middle that says presentations for fall conference. So you can just click on that and it'll take you directly there. Let's go ahead and record this. Did you already do that, Joy? I can't see.
Yes, I'm already recording, Pam.
Thank you. So yes, so we're recording this, and all of the webinar recordings will also be available at the same location. If at any point during this session you have questions, please post them on the chat. As I said, this is going to be a very interactive session, so I'm very much looking forward to hearing your voices and having you ask your own questions. Joy and I will be doing a bit of the moderating up front, but just so that you know, I'm really looking forward to hearing from each of you. There's that. Okay. So with each of our continuing education conference sessions, it's been approved for double credits or 3 credits for this 90-minute presentation. You get those credits from Mass DEP, and in order to get that, you need a certificate of completion, which we will send you once we can validate that you've registered and paid for the session, that you've participated in the session itself. We don't have a breakout room discussion. This is going to be one big open discussion, I think. And then also we will have the post-conference survey. So I've set up the survey so that it will mail to each of you within an hour of the session. If you don't see the survey for this session by noon, feel free to email me. But do look in your spam folders. I think several people, the message which comes from the survey tool called Qualtrics, I think several people found that going into their spam folder. So, but if you haven't seen it by noon, just let me know and we'll make sure you get it. Last week, we had a noontime presentation where we heard from Liz Harriman and Tiffany Skogstrom, just giving us updates on what's going on with the TUR program. We did record that, and that recording is available. Today at noon, we are just having a little half-hour networking thing. We've set up different topic areas. People who have already registered for that have indicated what topics they're interested in participating in, and I've set that all up. So it will be an informal, unstructured opportunity for you guys to talk amongst yourselves. And I really encourage you to take advantage of that. We do miss seeing each other, and there's so much that we learn in conferences beyond just our sessions, and we've missed that as well. So take advantage of this opportunity and let us know how it works for you. Okay. But there's no credit associated with it, and certainly there's no obligation to do that. So I know you're all busy as well. So if you can, love to see you there. So today we've done this little intro. We're going to hear from a couple of different companies about their experiences in implementing toxic cease reduction techniques. And then we're going to have a panel discussion. Our panel discussion was going to be moderated by our friend Terry McCormack at Umicore, but he had a little event this weekend, and he's not going to be able to join us, unfortunately, and he's very sorry about that. So Joy, Onasch, and I will be moderating the panel discussion, and then we'll just have a more open Q&A. Please, again, do share your questions in the chat at any point. But we will probably save the Q&A and the panel discussion, for the panel discussion and afterwards. So what I want to do first is, I'm so glad I put this in here. I forgot that I had a little poll that I wanted to share with you. One of the things that oops, I didn't want to do that. Okay, one of the things that we have heard from you all last week was that Zoom may not be the best tool for you. So I just wanted to launch this poll really quickly and ask you if you could just fill in, what webinar tools does your company or do you prefer to use? So yeah, go ahead and just give us your response on that. I'll let that go for a little bit more. If you use something other than what I've included there, please share in the chat what that is. We try to make this as useful for all of you as we can, but there's always something else that we can be doing, I'm sure, and something that we can be learning from you. All right, why don't I go ahead and end that polling, and I'll just share it with you. So Zoom is what most of you are using or are comfortable with or prefer, but it looks like Microsoft Teams is something that a lot are using. WebEx and GoToMeeting are also well used, and so I'll check out in the chat what the others are as well. But thank you. I just wanted to check on that, and we certainly want to, make this process as useful and user-friendly for you all as we can. And I know that Zoom has been an issue for several of you, so we apologize for that, but thanks for being here today. So let me just introduce our speakers. So we are going to hear from 3 different companies about their experiences. First, we're going to hear from Shuai Duo. He's the process engineer at Riverdale Mills, and he's going to talk a bit about what they did in the past year. Dan Lopes, the environmental manager at CD Aero, is then going to tell us a bit about what he's been up to, what they've been up to over the years. And then Greg Morose, who's the research manager here at TURI, is going to talk about the work that he did with outstanding bath refinishers. So what I'm going to do is I'm going to stop sharing, and I'm going to invite Shuai to begin. And Shuai, you can go ahead and just introduce yourself to us and go ahead and share your screen. Tell us a bit about what you did. Thank you.
All right, thank you, Palm. I really appreciate having this opportunity to talk with everybody. So let me just share my screen right now. Let's see how's it working. Does it work?
Yep. Perfect.
Okay, great. All right, so yeah, let me just give everybody a little bit of introduction. So my name is Shuai. I'm the process engineer in Riverdale Mills Corporation. I'm gonna introduce and share some of my experience about this project. The project's name is Dual Brushless Recycling System. So me and our team and the team from TURI, we spent like about 4 to 6 months and we finished the project. And the results are impressive, and I'm really excited to share everything. And let's get it started. So let me have some background. So Riverdale Mills Corporation, we're a wire mesh manufacturer. So we're making over than 3,500 different wire mesh configuration. We're literally in the mill and located in the Northbridge, Massachusetts. And we provide all different type of the wire mesh, such as the PVC coated, the galvanized, and plain steel welded. So we also supply different industry and business. So we provide mostly our product is lobster trap and crab pots, just like a picture in the shows the first one. And also we support construction. A lot of companies, they use our product as a rebar underneath the concrete. And also we provide our product in the agriculture, of course, for like a chicken cage. Also, we provide our products for security and landscaping. So pretty versatile products application. So how we make our products? So making wire mesh can be easy, can be difficult. So there's 5 independent production line in our plant. So firstly, we have a wire drawing line, we have a wire mesh welding line, and we have a wire mesh galvanizing line. So we're part of a galvanizer, and we're the member of the United States Galvanizing Association. And this galvanizing line is where I implement my dual brush recycle system. And also we do the PVC coating and the shear department. So in the wire drawing, basically we purchase a raw coil from our supplier, and we draw the wire into a specific gauge, like 8 gauge, 14 gauge, 12 gauge, depends on what the customer want. And then after that, we welded the wire mesh, all different kind of wire together. So we turn the wire to the wire mesh. Then once I finish the wire mesh welding, I will show you the wire mesh welding in next slides with a short video. After that, we do the wire mesh galvanizing. So the galvanizing process is pretty unique in our plant. It's different from hot dipping galvanizing. It's kind of different kind of with a continual galvanizing, but we still consider as a continuous galvanizing process. And this is where I import my project. After that, we do the PVC coating. So the PVC coating will provide a flexible, a soft PVC coat on the surface, which is about like a couple mils. This will provide extremely good protection for the wire mesh, so you can put in the salt water without corrosion and last about like 4 years. At the last, we cut out those roll, which is into specific dimension, into all those panels. So if we want to use for different, like we want to use lobster trap, we cut in 6 different panels and we send to our customer. They will combine them together, and you can use that for the lobster trapping. So in this clip, I'm gonna show you a short video how we do the wire mesh welding. So as you can see, there's 4 strips simultaneously welded on the welding machine. So those are the lobster trap wire. We're gonna send it to the galvanizer next step. But all roll is about like 800 feet, 900 feet, depends on customer one, and they will be coiled on the auger, which we call the spindle. So in the left side they have spindle carrier. On the right side we have a spindle pusher. So once the wire mesh is finished coil, they will be cut, trimmed, and it will become whole roll. And all this roll will be sent to our next step, which is called galvanizing step. So what is physically galvanizing? So the galvanizing is the process of provide a thin layer on the wire on steel. So there's a couple 2 different types of the galvanizing. One is called hot dipping galvanizing. It's pretty commonly used all different production of different application. You drop your stuff in the zinc kettle. And another one is called continuous galvanizing line. So which is the wire, the steel, and will be continually dipped into the zinc kettle. But before that, both of the methods need to be successfully prepared, which is mean all the parts. Doesn't matter if it's doesn't matter if it's a rolling mill steel. It doesn't matter. It's just part. They all need to be prepared, and that's where my process comes to. So if you look at the hot dipping galvanizing, it doesn't have the drag out and drag in liquid problem, but for continually you have to consider that, and that's where the problem and the challenge comes from. So I put a diagram for our process. So actually the preparation, which is surface preparation process, is combined with all different kind of tank, and is combined with all the water rinsing and acid cleaning and water rinsing and fluxing. So from the left, the wire mesh will be recoiled first, and it will continually dip into the first rinsing tank. So first rinsing tank will rinse all the dirt, the grease, oil from the surface. Then if we don't do that, it doesn't galvanize. It have some dirt on it, and you will have some bare spot. And after that, the wire mesh will continually dip into the acid cleaning tank. So in the acid cleaning tank, we maintain a low concentration acid. We're using hydrochloric acid, of course. Hydrochloric acid will remove the oxidation layer and will remove all those rust from the surface or prepare a clean, good quality wire mesh surface. And after that, the wire mesh will continue to travel through the second rinsing tank. So there's 2 baffle in there, which is a 3-stage backward washing tank. So in the tank, all the wire mesh will be clean. So the acid will be removed because we need to maintain a specific pH. So after that, the water mesh will continue to dip into the fluxing tank. The fluxing tank will prevent a thin layer on the surface to prevent it from oxidation in the air, and also will prevent it from people touching from all the other potential risks. And after that, the water mesh will continue to dip into the zinc kettle, just like as you showed in the previous slide, and you will have a shiny, good quality galvanized water mesh. But here's the problem. If you look at this diagram, the water mesh in the first rinsing tank, not only water mesh moved to the next tank, the residue on the surface of the residue, which is a liquid, we will call it drag out water, a drag out liquid, will continually be carried by those water mesh into the next stage, which is mean if you continue to run like a 90,000 pounds of the water mesh, the carry out water is not going to be underestimated. It will be a lot. And once all this liquid drag into the next clean tank, it will dilute all this hydrochloric acid in acid clean tank. As I show on the diagram, we want to maintain the concentration and the volume in acid clean tank. Of course, when the water mesh travels between acid clean tank to the second rinsing tank, it will drag out those low concentration acid to the second rinsing tank, which is what will cause the contamination in next, because we want to maintain the specific pH. And all those acidic water in the second acid rinsing tank will be drained into the wastewater, because we want to maintain the good shape of the rinsing water. So if we're doing so, we drain all those acidic water, which has hydrochloric acid in there. We drain to wastewater, and we have to use the sodium hydroxide to neutralize all this wastewater. And well, it gave us a lot of trouble, because we use a chemical just to fix all those drag out water, trying to figure out what's ways out. So as like I show in this showing the slide, where there are 3 different chemicals we want to fix. The first one is hydrochloric acid. Just like I mentioned, we're using it for the acid cleaning process, and it will remove the oxidation layer and rust. And also we use ammonium hydroxide to control the pH in the second rinse tank. If the pH is low, it will cause the flux issue, which is it doesn't literally galvanize good, and we'll have a quality alert on that. Sodium hydroxide we're using in the wastewater. Because we want to meet a regulation from the EPA and DEP, we need to make sure our water is in good shape for the discharge. So we need to use that to neutralize all the wastewater. But as you can see, all 3 chemicals is related with carry, drag out, and dragging liquid, because of this is continual process. So here's why we want to make a change. Firstly, we want to reduce the cost. We don't want to spend such a lot of chemical, just extra chemical in all of them. And secondly, we want to improve the galvanized yield rate. We want to improve the quality. If we always have a bare spot because the low concentration in the acids diluted by the water, or the pH getting too high or too low, my quality manager will pissed off. And also we want to reduce specific chemical usage, because we want to fulfill our toxic usage reduction action. That's our part of the responsibility. And last, we want to protect our employee, because the production operator, they are the personnel to moving all those chemical drum. They're adding all this chemical by themselves. Or if we reduce the usage, they don't have to do that very often. So those are 4 motivations we want to achieve. So what is the way out? There's several concepts we try to fulfill. Let's try to concept we want to know. We try to use air knife, but air knife is not working, because it blows all the acidic water everywhere, and it's pretty dangerous. And energy cost is not that low. We try to use some heater, like evaporate all this acidic water. Let's say you put a heater in the middle and evaporate all this acidic water on down, so that we imagine it will just magically disappear, which is not going to happen, because even you use a heater, you still have solid residue on the surface. And even I use on the wastewater, you still got to deal with those solid waste. So it's not a complete solution. It's a half-ass. So what we tried is one day when I was driving my car into the car wash system, and I literally look at all those spiral, all those rotating brushes, because the car is in different shapes, just like a wire mesh. The challenge of the wire mesh is it's not like a rolling steel mill. It's not a flat surface. Always have different shape based on what is the gauges you're using, what is the size of wire mesh. It's different. It's just like a car. So I would talk with my team. Can we use some brushes, something like that? We use the bristle brushes. I put one up, I put one down. We use this brush to physically remove it from the surface. How's that sound? So my team is surprised, and they never thought about something like that. Even they think it might work, but we don't know. So we did some tests. We literally put a brush underneath. Those brushes were used for clean the dishes, and we can see those residual liquid can be removed when the wire mesh is moving through top of it. So here's the final design. This is what we want to see. And this is a final project we finished after we implemented those dual brushes system. As you can see, they can liquid split on the top and will be catched by the top brushes, and they will collect them into the collection tank. So I talked with the Joy, we talked with the TURI, and they support us, and they give us funding, and they want us to implement this idea in our production line. So here's another diagram, same process, but the difference you can see is that I added two dual brushes tank between the first rinsing tank and acid clean tank, and the acid clean tank and the second rinsing tank. So on the first rinsing tank, the dual brushes, the wire mesh was still continually moving between the first rinsing tank and acid clean tank, but all this liquid will be collected, will be removed and collected in the first dual brush tank. And so we can drain it to the wastewater, but those are just water. There's no acid in there. And we can reuse them pump it back, or manually turn it back to the first brush tank. And the second dual brush tank is really important because it's the acid in there. So if I put a dual brush in there, the acid will be collected in the tank and will be pumped back to the acid clean tank. So this is a recycle. It's a recycle system where not only save it, we also pump it back, reduce the waste, and we prevent all those acid go to the next stage. So we'll prevent from the contamination. So it not only help with reducing the usage of hydrochloric acid, it also help to maintain the pH in the second rinsing tank. It also help maintain the pH in our wastewater system. So let's do it. So this is a BOM where I make the design for the whole system. On the left, you can see there's a shaft. I used bristle brushes. There's a vendor I work with, a kind of brown brushes. They customize the brushes for us, and we bolted with stainless steel and bolted on the shaft. And I designed a holding frame and a tank. So there's a two-plate support on the side, and the shaft that goes through the middle, and the wire mesh will literally travel through the middle, and the liquids will be removed by those brushes. So here's the drawing BOM, and this is 3D modeling of the tank, how this looks like. So as you can see, there's three different parts: the shaft part, the supporting part, which is frame and plates, and also the tank. So this is me and my maintenance team and mechanical team. They work with me, and they paint it with a frame, even it's stainless steel, and we're using fiberglass for the tank. I put up 3 buffers in there just to separate, and also we welded all this brushes. We put all the brushes on the shaft. We put them together. So this is what it looks like eventually. So you have the first tank and the second tank. All those tanks are in the same design, and in the second tank, actually I literally changed the second brush to the white one so I can identify what this looks like. So I'm gonna show you short clips so you can see what this looks like and how it works. So as you can see all the liquids attached on the bottom of the wire mesh. So zero liquids is really bad for our process. It causes the contamination, the diluted acid. So we have to continue adding hydrochloric acid just to maintain the pH. But you can see that the wire mesh is liquids underneath is continually attached with the brushes, and the first brush tank will make it a little bit, give it a little press on it so that it can fully contact with liquid. And see that the liquids will be removed physically from the surface and will be collected in the tank. So the two brushes, the height of brushes can be adjusted easily. Just depend on what is your product is. If for some heavier gauges, we make it a little bit lower. For some lighter gauges, because like it's some curve in the middle, so we make it a little bit tall, so that we can maintain the tension on the wire mesh. This is the first one, and this is the second one. I put bulkhead fitting on top so I can recycle all the acid. I have two brushes, one on the top, one on the bottom. I have a gearbox on the other side. I have a motor to continually rotate all the brushes. So it's the same one on the left side. Oh, sorry, on the left side is the water current tank. We use the water current to clean the water, so that this brush will prevent from all the acid liquids go to the next stage. So but on the left side, we have the acid cleaning tank. And also at the meantime, we have ultrasonic sensor at the back side, while continually monitoring the level of the acid. If this level getting high, they will connect it with the pump, and pump will automatically pump the acid back to the acid cleaning tank. So it will be automatic. It's the automatic recycle system. So this is how it's working. And this is a level. So it's 13 inches from the top. So I set up the number. If it's getting really high, that's about like an 8 or 9. It'll trigger the pump like this and pump out the acid back to 20, 25 inches, and it will start accumulating again. So believe it or not, the accumulation speed is really fast. It just take about like a day, 3 shifts, and it just get a whole tank of the acid. So this is how we learn in this project. So we come with the idea, and all my team support me. We need teamwork, and all my teamwork, and my manager, they support my creative idea, which is kind of like crazy, but it works. It saves us a lot of money, and we work with TURI, we manage all this project in 4 months. So it's not like a 5 years. The ROI we calculate, we just have a less than 1 year ROI from this project, and we utilize resources not from us, from our mechanics, but also from funding from TURI, and then we execute them together. So that's all we learned from this project, and it was really good. I can talk more in the panel discussion. So thank you guys for listening to me. I really appreciate this opportunity to share you guys.
Thank you so much, Shuai.
Do you want me to stop share, right?
Yes,
Okay.
thank you. So yeah, that's great. And one of the reasons, now while I'm doing this, Dan, if you want to go ahead and share your slides, we'll queue you up next. One of the reasons I really wanted to invite Shuai to talk about what he did is because he did such a nice job of really characterizing the process and making sure that he had like a really clear understanding of what was happening. And so that's something that we'll probably want to kind of talk about a little bit more. So I'm going to remove the pin for you, and there we have Dan Lopes. So Dan, I'm happy to invite you to talk about, do you want to go to the beginning of your slideshow? So Dan is, as I said, he's the environmental manager at CD Aero, and Dan has a really interesting story to share as well. So go ahead.
Hi, I'm Dan Lopes, environmental manager for Aero in New Bedford. Prior to April of 2019, our company name was Aerobox. We have been in New Bedford since 1938. We manufacture capacitors, electrical and electronic, for industrial, medical, and specialty applications. And over the years, we've been a very large user of toxic chemicals for product cleaning. Just as an example, when TURI first came out in 1990, we, our base year for our first TURI plant, we used 328,000 pounds of trichloroethylene for product cleaning. One of the processes in the manufacture of the capacitor takes place in the tank room. What we do is we take the capacitors and submerge them in the vacuum chamber where they're filled with oil or dielectric fluid. When the filling process is completed, the product is removed from the vacuum chamber. The solvents are used to remove the oil from the outside of the capacitor after the filling process is completed. That's a picture of a basket that those units are coated with oil, and they will go into the cleaning process. We relocated our operation to a new facility in the New Bedford Business Park in the year 2000. When we moved one degreaser from the old building that used trichloroethylene, and we installed a newly built custom vacuum vapor degreaser that used perchloroethylene. In mid-2004, working with Mass DEP, we contacted OTA for assistance. Our goal at that time was to remove the use of PCE, perchloroethylene, and trichloroethylene, and substitute it with an alternative cleaner that was environmentally safe, employee-friendly, and would clean our product as good as the currently used solvents. The replacement would also have to be cost competitive with the materials currently used. OTA put us in contact with TURI. TURI's first attempt was to put us into aqueous cleaning. We supplied TURI with samples of the oils that needed to be removed from the product. One of the oils was extremely thick, difficult to move even with the current PCE and PCE materials. TURI found that there were no identified aqueous products or detergents that would easily and efficiently clean our product, and especially the very thick oil. We then looked at other solvents that could clean the product, be safe, and cost efficient. We settled on 1-bromopropane, or commonly referred to N-propyl bromide. N-propyl bromide at the time was not a listed toxic. It was not reportable, something as an environmental manager I appreciated. Another good feature of the N-propyl bromide was that the vacuum vapor degreaser could be modified from PCE to N-propyl bromide with minimal changes in cost. We converted the degreaser that used PCE to N-propyl bromide in July of 2004 and eliminated the degreaser that used PCE by the end of the year 2004. In 2010, Massachusetts listed N-propyl bromide as a hazardous material. At that time, we stopped using N-propyl bromide as a cold cleaner on the production floor and as a thinning agent. In 2013, we again contacted TURI, this time to look at converting solvent cleaning to aqueous. As already mentioned, N-propyl bromide had become a hazardous material in Massachusetts in 2010. Also, we had eliminated the thick oil that had been a problem for aqueous cleaning in 2004. Equipment and detergents for aqueous cleaning had also improved. TURI really took the ball with this request. They took our products to sites where aqueous cleaning was being used, cleaned the product, and returned them to us for testing and inspection. The aqueous clean products passed all our inspections, including paint adhesion. By the end of the project, TURI had a recommended detergent, rust inhibitor, and a contact for a qualified equipment manufacturer. Unfortunately, the project was put on hold due to the capital cost of the equipment and the calculated asset loss of retiring the existing vacuum vapor degreaser. When we were purchased in 2019, the new owner wanted us to stop using N-propyl bromide as a product cleaner. Again, we contacted TURI for assistance. This time there were several reasons why to make the change to aqueous. Number one, the new owner wanted us to stop. The existing equipment was getting old and the maintenance costs were getting high. Massachusetts enlisted N-propyl bromide as a high hazardous material, and the EPA had now listed N-propyl bromide as a reportable material. This time we were confident the project would be completed. Again, we contacted TURI for assistance. We also applied for a TURI grant and received it. We supplied TURI with the currently used oils that needed to be cleaned from the product. TURI Labs did a series of tests using detergents that they had as well as detergents supplied by us. Cleaning tests were also performed by detergent suppliers and equipment manufacturers. Along with performing cleaning evaluations, TURI provided information on environmental and health and safety for each of the detergents tested. This greatly influenced our decision on the detergent we selected. Just as a note, trying to get this all accomplished during the time of COVID-19 was not easy. There were very few face-to-face meetings. Most contact was done over the phone, and even trips to the manufacturing site were eliminated due to travel restrictions. We purchased a cleaner we call a washer, manufactured to our specification in cleaning performance and product throughput. The machine is connected in our facility, tests are being run, and certification is close. Just as some information, the degreaser that you see is 23 feet long, roughly 6 feet wide, and about 10 feet high at its highest point. It has a continuous running conveyor, and the feed end and the extraction end are automated. Our current plan is to be N-propyl bromide free by the end of this year. And that's the end of my presentation. Yes,
Pam, you're muted.
I'm muted. Don't tell me I was muted all this time.
Pam.
No, I was muted. You were good. I, on the other hand, was muted. No, but thank you very much, Dan. I appreciate that. So what I'm going to do is, and again, folks, please feel free to ask questions in the chat. I'm going to go ahead and share my screen and invite Greg Morose to come to join us to talk about the process of working with outstanding bath refinishers. Let me see if I've got the right one here. I do. Okay. So,
I'm muted, right?
see that? Does that work?
Looks good.
Okay. Okay, so Greg, as I said, is the research manager here at TURI, and he's done some really interesting work with a number of companies, many of you on the line here. He's going to talk about a specific project. So take it away.
Great. Thank you, Pam. Good morning, everyone.
Greg, can I interrupt for a second? So you're a little bit garbled. I don't know if you need to be closer or further away from your yeah. Try again. Yeah, it's not great.
Try to get it closer. How's that?
Not great. Let's see.
Greg, do you want to log out and log back in? In the meantime, we have a couple technical questions to ask the other people.
Do that. Thanks.
Yeah,
Okay.
great idea. Thank you, Joy.
Yeah, so in the chat box, there's a question. Dan, can you unmute for a second? There was a technical question. You kind of cut out when you stated what the alternative was that you switched to from NPB.
I was trying to get unmuted.
Yeah.
Could you repeat that?
Yeah, you kind of cut out when you stated what you moved to from NPB.
When we move from NPB, we are at the new device that we bought is Aqueous.
Do you know the name of the product?
We're using, the material that we're using is Howard Hall supplied, it's Aqueous PL732.
Thank you. Sandra, did you get that? There are some other questions too about Shuai, your project. Let's see, people asked about the financials and I pointed them to our case study and the full demo on our website. People can find the link for all of that. But there's a question about the process of cleaning for the brushes. If it generates additional waste, do you need to clean the brushes?
Yes, I saw this question. So that's a really interesting question. So actually, that's a good part for the for using brushes because it doesn't really generate the waste, and instead it removes the waste and all those cleaning. Remember, I'm using a first rinsing tank, just using water, high pressure water to clean it from the surface. But the first brush tank help the rinsing tank to remove some grease which is not cleaned by the high pressure water. It's also clean it out and collect in the tank. So while I don't think they will create waste, and instead it will remove the waste from the wire mesh. And what you need to do is you just, I didn't have enough time yet because the brush is still red now, but I assume after 2 or 3 years, because we continually run the wire mesh, the brushes might wear out. So it might bend it. So the brush is like this, but after like a couple of years, it will bend it like a coil. So what they're gonna do is just reverse it. So we'll switch up and down. So all the bended will be running like this. So they will recurve all those brushes. So I literally expect the 5 to 10 years longevity of those brushes. The other thing I want to point out, because he's pointing about what's the process of cleaning the brushes. So that's a really good question. So we have a PM. So we have downtime. They have some small residue on the brushes. Basically, what I test is that you have a power wash, and you just power wash the surface of the brushes, and that's all you need. And you let the brushes rolling and power wash the detail of the brushes, and that's it. So, and the really good point of is our brushes, since it's a bristle brushes, you don't have to it's not literally like other textile that was texture on all the time. It's not. So it wants to sweep it from the surface, or just sweep everything underneath tank. So we have a weekly schedule to clean the ultrasonic sensor. So because we have ultrasonic sensor to measure level, we use ultrasonic sensor. We use the sweep and do the PM of ultrasonic sensor. We need to clean the tank inside of the fiberglass tank. We also need to clean the what we call the filter, where we have a filter to protect the pump. So we clean the filter. That's a daily job for our operators. So I have to generate some PM for our maintenance and operator, but I think it's worth. So it's like a one rock, three birds project to me.
Great, thank you. And thanks for stepping in and answering a couple questions. So Greg, say hello. Let's hear how that sounds.
Okay, hopefully this works better.
Yay, that's great. So, okay, we're gonna go ahead. I'm gonna unpin Dan and Shuai so that we can focus on Greg, and then I'm gonna go ahead and share your presentation. And that's not it. Bear with me. Stop that share.
There it is.
Did I
You
have
had it.
Oh, I saw the wrong thing when I did that. Okay, share. Is that the one?
There you go. Great, perfect.
Okay, okay.
Okay. Oh, good morning, everyone, again. So I'll be talking about how TURI worked with a local bathtub refinishing company to transition to using safer chemistries in their operations. And the chemistry that we're going to be talking about is methylene chloride. So methylene chloride is pretty much the industry standard for coating removal for bathtub refinishing, and it's been that way for decades. Works very well, and it's very cheap, and so it's been used widely. The issue is that methylene chloride is very dangerous to work with, especially when you are working in poorly ventilated spaces such as bathrooms. So methylene chloride contains a 1-2 punch from a health hazard standpoint. First, it's a depressant for the central nervous system. And second, it causes carbon monoxide buildup in the blood. So you put those two together and it's a highly dangerous situation. And as a result, there have been numerous deaths for bathtub refinishers that have been using methylene chloride paint stripping products. So this is a very real problem. And I even spoke with a bathtub refinisher that had a near-death experience using methylene chloride products. So this is something that's very dangerous and be very helpful to the industry if we could move to safer alternatives. Next slide, please. So the company we worked with is Outstanding Bath Refinishing, and they're located in Milford. And they've been in business doing bathtub restoration for about 20 years. And they use quite an extensive amount of methylene chloride, on average about 600 gallons per year. And so they applied for a TURI small business grant to help them transition to a safer product and move away from methylene chloride. So they applied for that and received a grant for that work. Next slide. So the first thing that we wanted to look at was make sure that any product that we switch to has a much improved environmental health and safety profile as compared to the methylene chloride based product. So we use the green screen methodology to do this comparison. It's a methodology developed by Clean Production Action, and it's used to compare chemical hazards. And it looks at a variety of hazard endpoints. And next slide. So which endpoints specifically? Well, here they are. So it looks at a variety of environmental hazard endpoints. It looks at a number of human health endpoints. They divide them into group 1 and group 2. Basically, it's group 1 are mostly chronic hazard issues, and group 2 are more acute issues. And finally, they also look at physical hazards such as reactivity and flammability. Next slide. So by using this methodology, you basically need to look at all of the available toxicological information for the chemical that's available in all literature. And based upon, there's a whole methodology on how to review all these data points, and then how to take that data and roll it into different levels of hazard. So it can be very low, low, medium, high, or very high. And if there's not enough information, then it's called a data gap. So you take all this data give it a rating for each one of the hazard endpoints. And this shows an example here of how you see some lows, mediums, and highs across the different endpoints. So you get all that information, and the beauty of green screen is it summarizes that very well, and that'll be shown on the next slide. So it takes all that that information and those ratings, and with the algorithm that it uses, it puts a chemical into one of 4 different benchmarks. So benchmark 1, 2, 3, or 4. So benchmark 1 is the most hazardous, and benchmark 4 is the safest. So there's those are the different levels that they have. So basically, the way we are looking at it for this project is, if it's a benchmark 1, it's considered a void. It's a chemical of high concern. So we don't want to be using that in any products. So methylene chloride is a benchmark 1 chemical, and we don't want to be using other benchmark 1 chemicals. So we would only consider alternative products that just contain benchmark 2, 3, and 4 levels for the chemical ingredients. Next slide. So this is a table of commonly used solvents in paint stripping products. So the ones that received benchmark 1, we would say avoid, and LT1 means, so what happens to do a green screen evaluation requires quite a bit of effort to do the work that's required to look at all the available scientific literature and to do all the ratings for each of the hazard endpoints. So it is time consuming and costly. So we don't have green screens for all chemicals. So for the ones that a green screen full evaluation has not been done, there's a thing called a list translator that looks at it's an automated translator that has access to a number of different authoritative body and regulatory body lists that have chemicals of high concern. So if it falls on one of those lists, say if it's a Prop 65 carcinogen, or if it's a European Union has been classified as a CMR, carcinogen, mutagen, or reproductive toxin, category 1, then it would receive a list translator 1 score. So we would consider that at a benchmark 1, even though a full green screen evaluation has not been done. So, so you can see, so if it's list translator 1 or benchmark 1, we want to avoid that in any possible replacement products. Next slide. So now that we had done the environmental health and safety evaluation, we wanted to do some preliminary performance testing on a number of different products. So we did that in the TURI lab. And so we had to create coupons to do this testing. And Outstanding Bathtub provided us those coupons. They were basically ceramic tiles, 4 inches by 4 inches, and they coated them with a first layer of a epoxy layer and then 2 acrylic coating layers. So it had 3 layers altogether. And so what we did was we put gaskets, these rubber rings, we glued those onto each tile so we could do 9 tests on each tile. So that way, when we poured in the paint stripper, which is typically a liquid, usually a viscous liquid, but we didn't want it to spill all over the place. So we were able to separate one tile into 9 different test areas. And we would leave the paint strippers on the surface of the tile for a predetermined dwell time, and then remove the paint stripper and then scrape and see what type of removal we had. So based upon all the tests that we did with various products, including methylene chloride products, we only found one product that had comparable performance to the methylene chloride products, but did not contain other benchmark 1 chemicals such as toluene, methanol, naphthalene, etc. And that product was a Super Remover professional grade product. Next slide. So after we did the TURI lab testing and we found a candidate that didn't have other benchmark 1 chemicals and had comparable performance to methylene chloride. We wanted to follow that up with some actual field testing. So Outstanding Bath used the Super Remover professional grade product for a number of bathtub refinishing projects, and we tabulated the results here. So first column is the type of bathtub coating. So the point here is every bathtub coating is not the same. There's different levels of quality. So we divided it into 3 different buckets for simplification. The first bucket is homeowners that use do-it-yourself painting kits. So they might have went to Home Depot, got a do-it-yourself painting kit, and then applied it themselves to their bathtub. And in general, these are the fastest and easiest to remove because they're not very high quality. And so for the number of jobs that Outstanding Bathtub runs into, this accounted for about 30% of their projects. The next level was a professional bathtub coating that they use higher quality coatings, but still not the highest quality. And so these were a little more difficult to remove, took a little more time. And then finally, so that was about 50% of the projects I run into. And then the third category is professional bathtub coatings, something that like Outstanding Bath or a company of that stature would provide that use the highest quality available coatings for bathtubs. And that's about 20% of the projects they run into have that level of quality coatings. So what were the results? So the third column is what were the results when you use methylene chloride, and the fourth column is what were the results when you use the Super Remover professional grade. So for the first category, the do-it-yourself homeowner, easy to remove coatings, both worked in 10 minutes or less to soften the coating so that it could be removed. So there was really no difference in performance for that. For the medium level coatings, there was a difference, but it was slight. So for the methylene chloride, it was able to remove and soften the coating within 10 to 20 minutes. But the Super Remover professional grade for this category of coatings took a little longer. It took about 15 to 25 minutes. So even though it was a little longer, it was still within a time frame that was not affecting the business operations of this company. So in other words, you couldn't leave something on for 5 hours because you just can't have a bathtub refinisher sitting around waiting 5 hours for a product to work. But for the little extra time that this required, it wasn't that significant. So that was considered acceptable. And then for the hardest level of coating to remove, both of them, you would need to apply the methylene chloride and the non-methylene chloride for 30 minutes. And even the methylene chloride doesn't remove all the areas. So it removes most of them, but not all of them. So at that point, they just remove the paint stripper and then sand whatever wasn't removed. Because again, they can't have too long of a dwell time because they just can't have technicians spending that much time waiting for something to work. So if it doesn't work in 30 minutes for the entire tub, they just sand what's left. And for both the methylene chloride and the Super Remover product, that was similar performance for the highest quality coatings. Next slide. So the economics. So for the economics, we just looked at the product cost. So for the methylene chloride based stripper, buying it in bulk volume, including shipping, was about $19 per gallon. And for the non-methylene chloride product, the cost, including shipping, was about $23 per gallon. So when you multiply that out by their average of 600 gallons per year, it costs about $2,000 more for the methylene chloride free product. Next slide. Okay, so to summarize the results of this work, The field testing results demonstrated to Outstanding Bath that they could eliminate the use of methylene chloride stripping in their operations. And there were no changes to the steps that they undertook for their restoration process, except for that one coating where it required 5 more minutes, but there were no extra steps or different types of equipment needed. So in summary, although the cost of the replacement is a bit higher, Outstanding Bath felt it's worth it for the safety of their workers in this, potentially hazard working environment. So they thought it made sense to transition to the safer alternative. So that concludes my presentation.
There we go. Now I am no longer muted. Thanks, Greg. So what I'm going to do now is I am going to invite Dan and Shuai to join us on a kind of a panel discussion. So there's some great conversation happening in the chat. And as I say, we'd like to get to inviting you all to ask your questions. But I have a couple questions that I want to just pose to the panel. And the first is really just to clarify motivation for making the change. And Greg, why don't I ask you first, for Outstanding Bath, what was it that got their attention? Why is it that they wanted to go through this effort?
It was a combination, they got notification that, from the, they learned that the EPA was banning and restricting methylene chloride. They knew that the supplies at some point in the future might be more restricted. And obviously with all the information that came out about bathtub refinishers and the recent reports by OSHA and other organizations, became more and more clear that even though they were trying to follow best practices in their work, there is still always some, potential risk to their employees using this very dangerous product in poorly ventilated areas such as bathrooms and apartment buildings, extremely with no windows. So, so even though there's a small increase in cost, they felt that it was well worth it for the safety. I mean, just one incident with the methylene chloride, you couldn't even put a price on that.
Right, good. Shuai, how about you? What was your motivation for investigating and making this change?
So mostly I have a lot of motivation, not only from me, but also from employee. I really get along with the production operators. They also mentioned that if I can find a way to let them not touch those chemicals all the time, reduce other usage, and also I want to improve, because I'm a process engineer, I want to improve the yield rate on the process to increase the efficiency, also reduce the chemical. I want to do all the stuff with a simple way. We don't want to spend like millions and millions of dollars on buy some fancy equipment, because I'm also doing mechanical. I've been doing mechanical designing for 5-6 years. I want to design a machine that I can using simply and straightforward. I worked with different vendors. So those are a motivation. I want to change, to make the process not just only fix a symptom, but also fix the problem by improving the process. That's all my ultimate target. So.
Great. And Dan, how about you? What was the motivation for change for CD Aero?
Well, it really goes back to when we were aerobots. We have been under a lot of pressure to restrict the use of toxic chemicals by both Massachusetts DEP and the EPA. Our volumes were so large that we were using, but the difficulty was there weren't really suitable changes or suitable replacements for mainly trichloroethylene. Trichlor 111 had already been banned. Trichloroethylene, like I said, was getting an awful lot of pressure. It wasn't only a toxic chemical, but it was also a volatile organic compound. So the pressure was there, but we just kept putting devices on to control emissions as much as possible because there was no suitable replacement for it. And we stayed with trichloroethylene. When we came to the new building, we introduced perchloroethylene, which wasn't getting as much attention, but was starting to because perchloroethylene was mainly used in the dry cleaning industry. So both of them were getting a lot of attention. We were working with Mass DEP, and that's when we started to look at N-propyl bromide. We were looking at it before we met with TURI. Meeting with TURI convinced us that that was the only vapor type cleaner that was an adequate replacement for trichloroethylene and perchloroethylene. So mainly our reason for doing it was the fact that we were just using toxic chemicals in very large quantities and needed to get away from that.
Mhm. So, I mean, so regulatory drivers as well as worker issues is what I'm hearing from you guys. And maybe just a really quick follow-up, Shuai, how are your workers responding to this change? Are there any concerns? Are there any, do they prefer what you've done? What are the workers' response?
So they really like it because it's automated process. They don't have to do cleaning unless they need weekly maintenance on that. That's the only thing. But during time, we already shut down the line. We pump all the liquid, just clean it. So I get a really interesting question on the says that is there any surrounding corrosive atmosphere problem? Actually, that's really interesting because we think about that. That's when we think about using the air knife instead of using the brushes. But the air knife will cause that corrosive atmosphere problem. But the different brushes, remember, the brushes submerged inside the tank. So all the liquid is physically it doesn't create a smoke or something like that. It's not gonna blow everywhere. It's literally sweeping from the top and clicking the bottom. They're not sweeping everywhere because that's how I design it. So they have 45 degree and sweeping into the bottom, and even they have some splitting and what to touch on the brush itself. Which is really interesting because now even from the beginning of design, I think about how they work because even you use a heater, the heater all evaporate all the second air everywhere. I'm pretty sure all my production employee won't like it. So that's a good part. I also have I saw the question about brushes, if it's good, if they get a corrode on brushes, some bio problem on that. So I would like to share my vendor. I can literally paste the link on my vendor. They are making brushes. The press is very fair. I didn't receive any advertisement from them. They didn't pay me for that. But what you can do, you can literally use brushes for yourself. If you have facing the same problem, you try that and you can design your rotation. It doesn't have to be a shaft. It can be different shape. Depends on what your parts is. But if it's a continual process, if it's a continual process, if you have drag out issue, the brushes will be an option for your process. That's what I'm thinking to share this idea. I can paste it here.
That's great. Thank you.
Yeah, no problem. They didn't. I wish they could pay me for that.
No, but thanks for doing that. I appreciate that. I'm just going to do a little bit more Q&A, and then we're going to invite people here to ask questions. So one of the things that Dan, the CD Aero story shows us, and I muted you guys, so if you could unmute yourselves, is that making a decision on the next chemical to use based purely on whether or not it is currently listed can lead you to make a decision that you have to actually change yet again. That was your experience going from PERC to TCE and TCE to N-propyl bromide and N-propyl bromide to aqueous. Comments on that?
Am I on?
You're on.
Well, yes, we have talked about this. We were pressured, obviously, to get out of TCE and perchloroethylene, and we went to N-propyl bromide. And we actually expanded it. We used N-propyl bromide for coal cleaning on the factory floor because it was considered to be safe. As soon as the state listed it as a hazardous substance, we stopped using it on the production floor. It was limited strictly to the vacuum vapor degreaser, which eliminates very, very little emissions. But from that time on, that the pressure started to get on to go to something else. And as soon as the opportunity came to go to an aqueous, we looked at it. Unfortunately, we had to back off in 2013 until just recently in 2019 when we started the project, and it's nearing completion right now. So yeah, we made a switch that appeared to be the correct one at the time, but in the end turned out not to be. But the decision we're making now to go to aqueous obviously is the right decision.
Yeah, and this is a story that I think we've all heard before, and it's one of the reasons why we now at TURI, and I think most of our planners now know to do a deeper dive, and certainly that's what Greg described when he talked about categorizing the chemicals that could potentially be an alternative, or the products that could potentially be an alternative. So, Greg, you talked about the whole green screen process, which is, as you say, a very rigorous process, and perhaps more than what a company would normally do. But certainly we want to encourage our planners to be thinking about the relative safety of alternatives they may be considering, and doing more than just looking at whether or not a chemical is restricted in some way by some, is there a regulatory limitation on it? That may not be enough. Greg, do you want to just add a little more to that?
Yeah, so basically that's the whole reason why we use the green screen methodology when we were evaluating the alternatives to methylene chloride for the bathtub. We didn't want to go to another product, even though it wasn't listed, but might have some concerns somewhere in the scientific literature. So there's usually always quite a lag between some hazards showing up within the literature and by the time it actually makes it to some regulatory list. So green screen kind of helps give you an earlier warning system. And the other thing about green screen is, if you wanted to do a green screen evaluation of a chemical that's never been looked at before, yeah, it is quite a time-consuming process. But there are so many available green screen evaluations already that are available. So, you can quickly access that information and benefit from others that have paid for all this work to be done. And so if you're considering a chemical and you look it up and it's a benchmark one, say, geez, all right, I won't consider that anymore. Or at least add that to your considerations. So as time goes on, more and more chemicals have gone through the process or have list translator scores. And all that information is available for most of the assessments for free on a database called thefarrowsproject.net. And all you have to do is just sign up for that, and you can get all of that information, all the green screen scores that are available. So you can search by cast number. So it's a quick way to get some very detailed information on the hazard profile of chemicals that you might be considering.
Right. Yeah. Thank you. And, really encourage our planners to be thinking about that when you are considering a change. not just looking at whether or not something is currently listed as a toxic chemical, but really taking a little bit more time to do some due diligence to make sure that it is in fact safer. Because as we know, science and regulations tend to lag behind the reality. So the Pharos project is a really good one. We have the P2 Oasis tool that you can access at TURI's website as well, which can help you in that. So let's see, I wanted to cover that, but I think at this point, what I'd like to do, there's a lot of really interesting chat going on. So what I'm gonna do is invite people to raise their hand, and you can raise your hand by clicking on the three dots that's sort of on the upper right corner of your little video screen. Raise your hand, or you can just raise your hand and maybe I'll see you, but better if you can do the raise your hand thing. And then I'll just call on you to kind of unmute yourself and ask your question. Come on, folks. Look at all of these questions that are going on in the chat. Let's hear somebody pose their question.
Hi, Lucy.
Go ahead, Lucy. Thank you.
Yeah, it was just a question for, I think it was Greg. What was in the super duper removal, professional, super remover professional?
Oh, yeah, so.
Active ingredient.
Yeah, when we showed the list of the ingredients that had benchmark 2, 3, or 4, I should have pointed out which ones are in the super remover product. So it has as a mixture solvent blend that contains methyl acetate, contains 1,3-dioxylane, and formic acid.
Great. Any other
Thank you.
questions?
So Sandra has a question. She can't find her raise hand, but so she's got a question.
Great. If you can find your unmute, go ahead, Sandra.
You'll need to listen to my grandfather clock and my cold. What was, excuse me, Greg, what was the second ingredient? 1,3-di what? Was the-
Dioxolane. Dioxolane.
Thank you.
And will that be described in the case study that'll be coming out?
Yes.
Yeah, so there is a case study that describes the whole outstanding bath process, which is just being finalized. So you'll get all of that information there. Did you have another question, Sandra?
Sure, while I'm on, I had one for, is it Shuai?
Shuai, yeah.
Shuai. Can you give me an idea of the time period? I think you said 4 months when you were talking about the ROI from start to finish. And when did you implement this, and how long has it been running?
Actually, I think it's on time study. So we literally started again last year in October, and after October, and after 2 months we finished put the first brushes, which is the one between the second acetylene tank and a rinse tank. And after that, because I went back to China, I'm from China. I went back to China. I get it back before the coronavirus, and I put another brushes in. So I'll be about 4 to 6 months. I could have been finished it because due to the holiday, and I have some family in China, so I'll get there. So take a pause a little bit in the middle. But to me, it's a project. If you continue get it, you can finish in the 4 months, no problem. Because I already be pre-designed. I spent a lot about a month to design the FMEA, to trying to think about what could be the failure on that. And I talked with TURI for a lot of time just to figure out, is that a bad for this type of the problem. So so it's from the start to the end. I would say probably will be if you think about the trial stuff, will be like 6 months. But if you don't consider trial stuff, 4 months. That's it.
Thank you.
And you can start literally. It's like an investment. You start to see all the liquid accumulated in that tank, and you just automatically pump it back.
Nice.
Thank you. So one of the questions that I have for each of you is around how did you actually get from the idea to implementation? So how did you make the case, or Greg and Outstanding Beth's case, you know, how did they make the case to go ahead and implement? Yeah, what were some of the things that you did that you had to do to be able to say, this is worth doing? And maybe Dan, we can ask you first. So you'll need to unmute yourself. There you go.
Yeah, okay. Well, again, I think one of the driving forces obviously was the fact that we were purchased, and the new owner definitely wanted us out of solvents. And so that started the ball rolling, and we had from previous years a lot of experience in working with TURI, so we knew that we had a source to go to assist us in this and make sure that we were in the right direction. We put the project forward. Now, I won't tell you it was totally creative. The new owners had an operation running in Mexico that also had an aqueous cleaner, but it was basically a commercial dishwashing system. And they basically said, here, we want you to do this. And we said that yes, we keep going aqueous is something we want, but we need a more sophisticated machine. And therefore, we just went forward with it. Aqueous has been on our mind since 2004. And now we finally went forward and did it and had the right motivations.
Right, and you know, and since you first looked at aqueous to when you actually implemented, both the technology changed and also you changed part of your process. You got rid of one of the most difficult to remove oils. So, right?
Well, yes, that played a big part, even with N-propyl bromide. And we went from perchloroethylene to N-propyl bromide. That oil was a difficult problem for N-propyl bromide. Perchloroethylene operated had a boiling point of roughly 190 degrees, which is good for reducing the viscosity of the oil. And N-propyl bromide was 140 degrees. And so it didn't work quite as well, but it still worked. And we went forward and made some changes to the product. We actually improved the product by changing oils. And so, you know, that made going to aqueous easier, more attractive. But the problem was in 2013 that the cost just was beyond what we could justify. And keeping in mind that we had a machine that was put in the year 2000 that cost us a tremendous amount of money, and we would have to write that off, because going from perchloroethylene to N-propyl bromide, the same piece of equipment could be used. Going from N-propyl bromide to aqueous, the machine became obsolete. So we finally did make the decision in 2019, even though we wanted to make it earlier.
Right, and so, you know, your project was a huge capital project. What Shuai described in Riverdale Mills was also a big capital project, but not, I think, to the same scale. And what Greg has described is really switching from one product to another, and so much smaller scale, but also a much smaller business. How did Greg, how did Outstanding Bath go from their motivation to the decision to do it? What was the key to implementing, to saying, yes, we're going to make that change?
Well, I think the key for them was performance. So when we had the results in the TURI lab, you know, the different products, and said one looked like it was comparable, like, well, that's nice. We really need to try it in some real applications, not in the lab. Yes. So I think until they tried it on all those different levels of quality coatings in actual jobs and projects, and found that they could actually use it within the same time frame for their current process, that's what really, you know, convinced them that this is something we can work with. Right. So short of that, they would have just said, you know, because it's such a time critical. I mean, that every time I talk with them, like the scheduling, you know, making sure that someone goes from one project to another. So you really could not afford, you know, significant extra time to do the stripping process. So that was a key factor for them.
Right. So Shuai, how about with Riverdale Mills? You also talked about quality being part of the impetus or part of the characteristics that you had to pay attention to. What was the key to management saying, yes, we want to move forward on this?
So there's several of them. You need a guy to literally push out this project from the beginning. Yeah, push it, and push it not to your motivated not from your employee, from your operators. You push it to your boss. Look, this is what you're challenging, and I have a solution. Even they have support from TURI and from the grant. Of course, the budget is just an important part. You push it to your boss, and your boss say yes, and you get a proof what your achievement, what you got. You also have an execution team who can do that, and you have, just like I mentioned, you have resources. You need to know who making all the brushes, right? I spent like a couple of weeks trying to talk with all the vendors who can customize all this rotation brushes. I finally found one. And they said, oh, it sounds like a really good project. So let's work together on that. So I get a discount price from them. They want to know if it's working or not. So we work together, and I did all the designing, all the stuff just myself. So my boss asked me, what are you doing there all day long? I said, all right, I'm trying to design a shaft. I'm trying to put all this damn brushes on the shaft, make it a rotation. So it's literally need one to push it. You need a team support you. And once you have resources, you prove to your boss, and your boss says, okay, it looks like a good idea. Give it a try. And we give it a try, it works. And actually in the coding line, we plan to do the same thing, because it's a process similar. Okay, we can utilize all those brushes, and those brushes are reusable, can use them over and over again, unless your shaft. Other shaft is stainless steel, so you don't have, it's not corrode. You can reuse them for 15 years.
Yeah.
So it just need a team. It just need a team. They need a reasonable boss who would like to listen to your crazy idea.
Yep, that's great. So Sandra, I see that you have a question. Can you make it really quick? Because I do want to wrap up on time. So you're muted.
Thank you. Shuai, did you use SolidWorks?
SolidWorks.
Yeah, okay.
Yeah,
That's all I wanted to know.
Yeah, make solid from all the small parts to the whole assembly.
And you can do the
I'll be
3D,
there.
rotate it, and do the trial and error before you even go to the machine shop.
So you need to go to the field. You measure all the dimension, make sure you have enough space, and then you make it an assembly in your SolidWorks. And once you have all the part design, you give it to your machine shop, local machine shop, say, look, this is what I need, this is part what I need. And once you have everything, you assemble in your plant on-site, and you install on the production line, and give it commissioning.
This has been really great. All of you, this panel has, I think, told the story of toxic cease reduction planning in such an interesting way, right? We have a problem. And something that we want to change. We have identified the reason why we want to change. It's impacting our workers. It is a regulatory issue, whatever. We understand why we're using that chemical or that process. We really dive in and we work with a team. We have a champion who helps us to really kind of investigate fully. We don't just rely on initial results. We do additional field testing. We do pilot testing. We talk to our peers in another facility. And we take all of that information to make the case to change. And so I just, toxic cease reduction planning, whether you realize that's what you were doing, I think each of these cases definitely displays that it works, and that it can lead you from a huge project to a small project, from we are using a toxic chemical to we are getting to a point where we don't need to be using as much or any of a toxic chemical we want to get away from. So a really terrific panel. I want to thank each of you for joining us. Thank you all for sharing your questions on the chat. I don't think we were able to get to many of them. Yep, Joy.
Just that someone put a tip in the chat box about how to save the chat. I think if you go to file in the bottom right and you can save it, because there was a lot of links and answers in there. If you want to save that for yourself for future reference. And also if your questions didn't get answered, feel free to follow up with us.
That's exactly what I was going to say. Thank you, Joy. So again, thank you everybody for joining us. This was a really great panel discussion. I really appreciate your time. I encourage people to join us at noon for our informal networking, or to join us again at 3 o'clock, right? For our last session where we're going to be focusing on making the business case. So again, thank you all. Have a wonderful day.
Thank you.
And thanks again, panel.
Thank you.
You're welcome. Thanks.
Thank you.
Bye, everybody.